Okay, guys, happy virtual day. We're going to take some derivatives of trig functions, and it's really not hard. I've pre-written everything. So again, if you would pause and take a moment to copy this whole top section down, it should be good for you. We'd be able to get this done much more quickly, but pretty easy. Derivative of sine is cosine, secant is secant tan is secant squared. Cotangent is negative cosecant squared, cosine x is negative sine x, and cosecant is negative cosecant x, cotangent x. Notice all your c's have negatives. Something to be aware of. Okay, so first thing is we're going to take a derivative of 5x cubed sine x. So if you're looking at these, this looks like its own function times another function. Oh, a product rule. So we're going to need to do a product rule here. So the derivative would be first times the derivative of the second, the derivative of sine, look up there, cosine. So first have derivative of the second plus second sine x times the derivative of the first. Now be very careful here. Sine x is its own quantity, remember? So you want to multiply it by this derivative. You don't want to think of this x as you're allowed to multiply the x and then what we get from here together. You can't do that. But the derivative of 5x cubed is 15x squared. And what I would suggest you do is just putting that out in front of sine x, so that your final answer would be 5x cubed cosine x plus 15x squared sine x. You cannot take that x and multiply with this x. They're totally different. This is the sine of x. It's not allowed to be separated. All right, now I've got number 2, which looks like it's cosine x over 4x squared, a quotient rule. So let's see. I would do denominator times the derivative of cosine. Again, look up at your chart there. Derivative of cosine is negative sine x minus the numerator times the derivative of the denominator. So I'll put a parenthesis there. So this would be 8x all over the denominator squared. And now let's clean this up. This would be, I like to call it negative 4x squared sine x. I always like to put the monomial in front. This 8x, I'm going to write minus 8x cosine x. And divide that by, this would be 4 squared, and this would be x to the 4th, so 16x to the 4th. Now, all of these monomials in front can reduce. So we're going to reduce them and get a much nice cleaner answer. So let's see. 4 can go into 16 and 8. What number can go into all of them? 4 can go into all of these numbers. There'd be a 2 here and a 4 there. So I would have a negative. Let's see about x's. This is x squared, this is x to the 4th, and this is an x. So an x can go into all of them. So that x would go away. This would become x to the 3rd, and this would just become an x. And then sine x and cosine x, you just can't touch. So this would be negative x sine x minus 2 cosine x over 4x cubed. That is your derivative. All right. One more here. 2 cosecant x plus x tan x. So again, if I'm looking at the derivative for cosecant is negative cosecant cotangent. Negative cosecant cotangent. Well, what if I have a 2 in front? Well, we've talked about this before when we have these coefficients in front. They kind of just attach themselves. You could do a product rule here. but what you'll end up is with the coefficient in front. So this would be, the derivative of this would be 2, and the derivative of cosecant is negative cosecant cotan. So put the negative here, cosecant x, cotangent x. Then this right here is again a product. So I'm going to have to do the whole first times derivative of the second. So first times the derivative of tan, looking at your chart, is secant squared x. First times derivative of second plus second, which is just tan, times the derivative of x. That's just 1. So let's see if we got anything to clean up. I think this is it. Yeah, that's it. That's done. Okay, so not too hard. It's just look at your derivative list. All right, and now we've got this idea of higher order derivatives. We've kind of already done it when we talked about acceleration. Y prime, f prime of x, and dy dx are all symbols for a first derivative. But we could have a second derivative, d squared y over dx squared, like that. That would be a second derivative. We could go all the way down to y to the 4th, and we actually don't make 4 marks. We actually write it like this in parentheses. Y to the 4, f to the 4x, and then d to the 4y over dx to the 4th. These are just symbols to take higher order derivatives. So we're going to take a derivative of second derivative of secant squared x, a second derivative of secant squared x. Now, remember, this really is secant x to the second power. And we haven't done what's called the chain rule yet, which we will get to, because when you have something raised to a power, you have to do an extra step. So what you want to think of this as is secant x times another secant x. That's what secant x squared is. And so we're going to take a derivative of that with product rule here. So that would be first times the derivative of secant x, if you look at your list, is secant x tan x. First times derivative of second, plus second times derivative of the first, which again would be secant x tan x. So let's clean this up. Secant times tan is secant squared x tan x. And we have another secant squared x tan x. And again, what does that clean up to be? Well, that cleans up to be, look, you have 2 of these. Secant squared x tan x, secant squared x tan x. You have 2 secant squared x tan x. That is the first derivative of that function, but we need to find the second derivative. So what do we do here? So this can get a little interesting. So we're going to take the derivative of this, which would be, again, this is your first, this is your second. So we're going to take second derivative. So it'd be first, oops, I didn't want to have that parenthesis there. Excuse me while I white it out. First times derivative of the second, which is tan. So the derivative of tan, again, if you look at your sheet, is secant squared x. First times derivative of the second, plus second times derivative of the first. Let me write this out for you. the derivative of the first? What is the derivative of 2 secant squared x? Or what's the derivative of secant squared x? Well, we just found the derivative of secant squared x. That is the derivative of secant squared x. Let me write it like this. The derivative of secant squared x was 2 secant squared x tan x. So if I have 2 secant squared x, remember I keep that coefficient and I multiply it by this, which would be times 2 secant squared x tan x. Now, clean this up. So 2 secant squared x would become 2 secant to the 4th x. This is tan x times 2 times 2 times secant squared x times tan x, which would be, let's go. 2 times 2 is 4. I got a secant squared, and I got a tan times a tan, which is a tan squared. That is the second derivative of secant squared x. Now, I'm going to be real honest with you. I do not like the way they teach this. This is going to be so much easier to do when we do what's called the chain rule. Okay? If this was partially confusing to you, really, if you could get up to the first derivative, I would be happy about that. The second derivative, when we do the chain rule, it'll make more sense. But that's what we're doing. We're taking the first times the derivative of the second plus second times the derivative of secant squared x is this thing right here. And so we just had to put a little 2 in front of it. So again, please don't fear if this was confusing for you. It will be much more clearer with chain rule. That's why I like this book, but then again, at the same time, I don't like this book for that very reason. All right, one last thing. Find the equation of the tangent line of f of x equals cotangent x. F of x equals cotangent x. So again, look at your little sheet there. Derivative of a cotangent is a negative cosecant squared x. So I know that the derivative is negative cosecant squared x. Now, I need to find the actual slope value at the point pi over 4. So I need to find what is the slope at negative cosecant of pi over 4, and then I am going to square that. So cosecant is, remember, the reciprocal to sine. So the sine at pi over 4, if you got your little unit circle, they're both the same, root 2 over 2, root 2 over 2. So the reciprocal of root 2 over 2 would be 2 over root 2. And you're going to square it and get what? Well, 2 squared is 4. Square root of 2 squared is 2. You still have this minus on the outside. So my slope is negative 2. So I have a slope. I need a point. I have half a point. How do I find my y value? Plug it into the original. Y equals the cotangent at pi over 4. Cotangent is the reciprocal of tan at pi over 4. So tan, remember, is sine divided by cosine. That would be 1. So the reciprocal of 1 is just 1. Okay, so my point, it's going to be weird, is x, which is pi over 4, and the y value 1. So there's your point. There's your slope. Put it into the point slope formula. y minus y1 equals m times x minus x1. And then clean this up a little. Let's see, y minus 1 equals negative 2x. Negative 2 times negative pi over 4 would be 2 pi over 4, which is just pi over 2. And then add 1 over. Plus pi over 2 plus 1. You could call it 2 over 2, but then it would just be pi plus 2 all over 2 for that one. It's just better to leave it like this. Looks strange, but that's how you do that problem. So homework tonight, 3.5, 175 to 184, 185 to 197, every other odd. Every other odd. Okay, shouldn't be too bad. Just practice. Look out for those, trig identities that you should know and love. Have a good night.